Hi, hello everybody. So this is the video dealing with section 3.3, properties of logarithms, and this is the third part where we use a particular formula when we have to evaluate a numerical log that we cannot simplify, for example, such as in the examples I gave in the first video. So for example, consider this log expression that I gave you before. I know that the answer to this, according to the definition of logs, is an exponent that will go here such that 2 to that raised to that exponent would be equal to 8. So obviously the answer is 3 because 2 to the third power is 8, right? 2 times 2 times 2 is 8. Now, sometimes we have numbers that we cannot do this. We cannot find an easy value here. So for example, how about log base 2 of 7? Now it's not possible, right? 3 gives me 8 and 2 to the 2 gives me 4. So I know it's a value between 2 and 3, but what is it? So we don't know. So there is a way to do this, and this is called the change your base property, which is pretty much the formula that you see over here. Now, if we have the log of a particular number using a particular base, then I can come up with a new base, and it's going to be log of the number divided by log of the base. All right? Using whatever new base you want to. So normally, because the calculator has log base 10 and log base e, we normally use either the base 10 or the base e because the calculator provides us a way to do that. Now, whether you use the common log or the natural log, it doesn't really matter. The answer comes out to be the same. And I'm going to show you that with the examples I have here. Okay? So, in general, the example I gave you, log, let's say I want to do this, log of 7 base 2. Cannot do this on the calculator because maybe your calculator doesn't have a base 2. So this is what we do. We say log, and let's say that I want to use base 10. Log base 10 of 7 divided by log base 10 of 2. Now, I can do this with the calculator, I can do this with the calculator, and I certainly can do the division with the calculator. So this becomes a doable problem, whereas this, not so much. All right? So let's take a look at the examples I have here, and I'm going to show you that it doesn't matter if you use the common log base 10 or the natural log base e. So I have a few examples. Let's do example 7 first. This is something I cannot do, just by visual inspection. I have to use the calculator. So, and I'm going to use two ways to do this. I'm going to use log base 10, and I'm going to use log base e to show you it's the same result. So log base 10 of 140, log base 10 of 5. Okay, I'm going to do both on the calculator. Now, the answer is going to be the same as if I were to use natural log or log base e. Now, so remember that log base e is what we write as natural log. So I'm going to say natural log 140 over natural log of 5. And the answer will be the same for both. So now I have to use the calculator. There's no other way. So here's my calculator. And I am going to use the log function first. Notice that the log function here means log base 10. And right underneath it, I have ln, which means log base e. So I'm going to do the first one first, log, and this is log base 10. I'm going to put 140. and then divided by log base 10 of 5. And this is the answer 30704. I'm going to write it over here, approximately with 4 digits. And now let's do the same problem using natural log. So I click natural log, 140 divided by natural log of 5. And the answer should be exactly the same. So 30704, this is exactly what we got. Just to show you that it is the same answer. So you can either use log base 10 or log base E. All right, so I'm going to do a couple more only. I have a few examples. If you want, stop the video and you can try the other ones. It's all the same. I'm going to only do 2 more. Okay. I'm going to do maybe one with a decimal as the base. Remember, the base can be any number positive other than 1. And I'm going to do maybe the one with a pi, right? Using pi as 3.14. They're both the same. I'm going to do this one maybe using log base 10. And I'm going to do this one maybe with natural log. And then you can check to see that the answer is the same, whether, just as I did over here, whether you use base 10 or base E. So let's do 76 first. So I cannot evaluate this way, even with the calculator, because the calculator doesn't have a base 0.3. But that's okay. I can use the change base formula right here, which would be log base 10. No, wait a minute. There's no equal sign here yet. Log base 10 of 19 over log base 10 of 0.3. So now this becomes a problem I can do, right? Because the calculator uses base 10. So I'm going to go to the calculator and put this information in. LOG for log, and this is base 10, 19 divided by log. Now don't mix them up. If you use log base 10, use log base 10 for the numerator and denominator. Log base 10, 0.3. And we get the value negative 2.44. Negative 2.44 approximately. And that's my answer. I'm done. There's nothing else to do here. In the other example, I'm going to use natural log for 78. Okay? So for 78, I'm going to write natural log of 400 divided by natural log of pi. Now, and obviously, I'm going to approximate pi as 3.14. So this is going to be approximately, and you can do both again, same as before. Natural log, what was it, 400, right? 400 in pi. 400 divided by natural log of 3.14. Okay, and that would be my answer, 5.2362, or just 5.23. Approximately 5.23. And again, you can verify, you can do this problem with log base 10, and you can do problem 76 with natural log, and you would get the same answer. So in the event that you are asked on an exam or homework to evaluate a numerical log expression, you may have to use the change base formula, as you see over here, or property, and either use log base 10 or log base E, the natural log, to evaluate the expression approximately.